I'm Alessio Carpegna from the Smileys Group at Politecnico di Torino. In this series of tutorials I will show you Spiker Plus, which is the framework I developed during my PhD, to automatically generate FPGA accelerators for spiking neural networks targeting low power and resource-constrained edge applications. First, let's go a little bit more in detail in what spiking neural networks are and why do we need to accelerate them. Spiking neural networks are a particular kind of artificial neural networks which is inspired from how our biological brain works. First of all, neurons exchange information in form of streams of very short pulses, which are called spikes. And because they elaborate these streams of data, they are particularly suitable to elaborate temporal series, like audio signals or biological signals. Working in the digital domain, as the one of FPGA or microprocessor is, spikes can be represented as single-bit events, and this representation allows to save memory and enables lightweight information processing. Designing a spiking neural network accelerator, there are many knobs that one can tune. In particular, the architecture of the network can be feed-forward or can contain recurrent connections. The model of the neurons can be configured trading off biological plausibility, power consumption, and computational efficiency. And the hardware implementations of the network can involve many different architectural choices. To solve these complexities, I created Spiker Plus, which is a Python framework to automatize all the steps that are needed to configure, train, and deploy a hardware accelerator for spiking neural networks. In these video tutorials, I will guide you through all the steps that are needed to tune the accelerator on a specific dataset until the generation of the VHDL code which describes this hardware accelerator.